Good afternoon and welcome to this week 8 problem solving session for this NPTEL course Transition Metal Organometallics in Catalysis and Biology. Myself Shubhajit Kundu hosting this session as a NPTEL PMRF TA for this course. So, like the previous session of this course, first I will discuss 10 questions which is related to this week 8 content, and also these questions are very related to the portal assignments. After discussing the 10 questions, I will discuss some important topics from this week content to summarize the week 8 lectures. I hope this session will be helpful to solve your weekly assignment as well as to solve the questions in the final examination. In this series, mainly we discuss problems and their solution approach. That means how the solution is approaching and there is a different or number of ways to reach the correct answer in this type of multiple choice questions. That means there are many tricks to find the correct answer for the question. We are going to discuss that. We have already discussed few of them in last 7 problem solving session, and I hope you will, or whoever is watching or will be watching these videos, that thing will be helpful during your real examination time. So after show up a single question, there will be a 13 to 15 or 30 second of pause just to remember the answer for whoever will watch him, and then I will start discussing the answer with the mechanism. So this I will wait for few minutes, 1-2 minutes, if any others join. After that I will start discussing the session. Okay. Okay, as nobody joined, so I believe if anybody joined in between, I will try to get their answer, get clear their doubt. So just I am pinning a message. If you have any doubt, please unmute yourself and try to answer the question displaying I am sharing which which okay. So if anybody join, they can see this in call messages, and if you have any doubt, you can unmute yourself and ask me and try to answer the question, and try to which I am sharing. Okay then, if nobody join, let's continue the session from my side. Hope this somebody will watch this video, and if you have any question, you can mail me in the following email address. I have already shared in the screen in that thing, or in that presentation, or in the Google Drive in an every week content, every week slide, that is mainly the questions. So I have shared there, so you can just email me if you have anything, any doubt, or if you have any doubt regarding the portal assignment, that means which is shared in the portal, or in the lecture which is delivered by the instructor, or in the assignments, you can just post it in that discussion forum. I will try to answer this thing as quickly as possible. So with that, I try to start today's session, and welcome again to this thing, NPTEL problem solving session for transition metal organometallics in catalysis and biology. Okay, so our first question is, so before going to the question, let's summarize that today in this content. So like the previous week, we have completed the reaction, metastasis reaction, that is the olefin metastasis reaction. And alkyne metastasis reaction also we have finished, and then we have moved to the another reaction, that is that and after that oligomerization reaction and cyclotrimerization or cyclo-oligomerization reaction, we have moved to our last topic on this catalysis series, that is the application of organometallic compound in catalysis, that is the polymerization reaction. We have just started the polymerization reaction in the last lecture. In the subsequent lecture, that is in the next week, we will discuss in more detail the that polymerization reaction. Okay, so the first question is, the demersal process is used to produce. So this is the first question. So if you have any doubt, you can ask me, or if you not, you can answer this question. Uh, or I will try to continue. Then I will wait for the answer. Then I will try to continue. Okay, so uh, so in this week we have started that oligomerization reaction and the cyclo-oligomerization reaction. So here there is an important process happens, that is called the demersal process. So in this process, we have seen that the reaction of if you know the answer, okay. If you don't respond, then I will continue this session from my side. So this is the first question of today's session. So this is that this thing. So the demersal process is used to produce. So this is a process which in which we undergo the propane dimerizes and give the branched hexane is called the demersal process. So in this process we will discuss it later. We'll discuss in detail. So here in this process we produce the branched hexene, and that branched hexene is when hydrogenated, it is reduced then this produce the petrol. So the dimension is used to produce the petrol. So option D will be right answer for this question. Okay, so I will discuss this process in detail in the upcoming question or at the end of this today's presentation. Going to the next question is, the correct sequence of the dimensional process is that the first option is the hydrogenation and dimerization, trimerization and dimerization, dimerization and hydrogenation, and trimerization and hydrolysis. So we have already seen that the process involved this process involves the dimerization. That is, if you have of these this, that means we have number of, let's say, 2, so it will dimerize in presence of a catalyst to so number of branched dimer, uh, like this, and the last is this. So all these thing, when we that undergo the hydrogenation, that is H2, if you say that, that means the reduction. So this is means the reduction. This will undergo the simple alkene, give the alkane, and this will used as a petrol or liquid fuel. So this process, and so the first step is the dimerization, and the next step is the reduction. So like this, in this question, let's say if you remember that reduction, or reduction means the hydrogenation. Reduction means the hydrogenation. Okay, so if you see the thing in the question properly, that the hydrogenation is the last step of this, in this process. So that whatever happened in the first step doesn't matter, the hydrogenation will be last step to give your petrol. So in this reaction you can see that hydrogenation, only the option C contains the hydrogenation reaction in the last step. So like if you have any idea, or if you become confused the dimerization and trimerization reaction, so you just need to remember that without hydrogenation this process is not completed. So the answer will be dimerization and the hydrogenation. So option C will be the right answer for this question. Do you have any other question? If not, then we will continue this session. If not, then we will continue the session from this. Okay. So next question is the ligand that stabilizes the nickel precatalyst of the ethylene oligomerization step in the SOAPS process. Okay. So we have seen that the soap process involves the nickel catalyst, and here the importance of the ligand or around the nickel is very important. So here the correct answer for this will be option A and option D, which stabilizes the nickel complex in the stabilizes the nickel pre-catalyst for the oligomerization step. So this question we will discuss in detail at the end. This is a very important question to discuss. Okay, so here option A and option D will be the correct answer, or we can discuss it now also. Let's go to 11. Okay, then discuss now. Let's discuss this question in little bit in detail to get an idea how this reaction thing is produced, or the details of this process. Okay, so in our case, that is the soap process. The pre-catalyst is nickel, whereas the structure is nickel is bounded to, here it is bounded to oxygen, and here it is bounded to phosphorus. Phosphorus, and we have this ligand double bonded O here, and phosphorus is attached to pH and pH. So here it have a cyclooctadiene cyclooctadiene ligand, or cord ligand. Now what will happen? This cyclooctadiene ligand, this ligand will eliminate this. This will eliminate, and then this will perform a pH pH O nickel hydride. So now these species act as a active catalyst active catalyst active catalyst for shop process. Okay, so now this one is the active catalyst, and for our question we are concerned about the pre-catalyst. So this molecule is called the pre-catalyst. Okay, so there is a difference between the pre-catalyst or active catalyst. So the pre-catalyst is which we made in real, or you heard will made in the bench as a stable molecule. Now that stable molecule may not be actual catalyst for the reaction. So that is the just one step before the active before the catalytic molecule which take part actually in the reaction. So that's why we call these types of molecule as a pre-catalyst. That is the which is that pre-catalyst means the catalyst, the molecule which is going to be catalyst. Okay, So now is a nickel hydride complex which acts as active catalyst for this reaction. Okay. Now go to the that question. So A and B at the A and D are the two ligand, that is the phosphorus containing ligand, and the D is the cyclooctadiene. This is called the COD, cyclooctadiene COD ligand, which stabilizes the precatalyst in the soap process. So with this we go to the next question of today's series. It is the correct statement among the following reaction are. So this question is very important question from this in this week content, that is the this called the trimerization reaction, and so here the tantalum TaCl5 is used with the tetramethyl tin complex along with this. So here we have to identify the correct statement for the following reaction. So here that that one thing you need to notice, that in the question they mentioned that correct statement or with the yes. That means here you need to very cautious that more than one question. That means it is a MCQ M not type of question, it can be the MSQ type of question. Also when you see this thing of kin, that is or are or product or products, kindly be extremely cautious when these are you have that may have multiple answer type question. Okay, so multiple answer type question. But this is or are does not guarantee that it may be multiple answer. It may be a single answer type question also. Let's start discussing this question. So here you can see that we have 3 of ethylene molecule and it undergo the oligomerization reaction to produce 1, 2, 3, 4, 5, 6. That is called is called 1 hexene. 1 hexene. So we'll discuss the mechanism of this reaction. So this is the catalytically active species is tantalum 3 intermediate. Yes, the catalytic active species is a SN4 intermediate. No, SN4 is already present, which is not catalytically active. The reaction proceeds via the formation of 5 member and 7 member metallocycle intermediate. Yes, and the catalytic cycle terminates with the reduction elimination step. Yes, so here you can clearly see that option A, option C and option D are correct, but option B is not correct. So this is a qualify the type MSQ, and without knowing the mechanism of this reaction it is very difficult to predict the mechanism or the thing, the intermediate or active species for this reaction. So let's discuss the mechanism of this reaction. Okay, so that the pre-catalyst is a mixture of TiCl4 and the catalytic agent like the Me3 Al or SN Me4 tetramethyl aluminum or trimethyl aluminum or tetramethyl tin or dimethyl zinc or N-butyl lithium is a reagent. So this reaction is called the trimerization of ethylene. This reaction is called the trimerization of this reaction is called the trimerization trimerization of ethylene. Okay, so first we have that catalytic intermediate which is active species is TiCl4. Now it converted to TiCl3. So the first intermediate will be converted to TiCl. Okay, so TiCl3. What is this? TiCl3. Now this TiCl3 will have this with these two ethylene molecule and it will coordinated as Cl3 Ti So this is a five member five uh, five five member metal cycle ring. Now the another ethylene molecule will coordinate to give the ring size 5 member to 7 member. So this is a tantalum catalyst. What is happening here? So TA, so there it will be TA. So that will be a 7 member ring, 7 member ring formation. Now this is undergo the again to the intermediate with the elimination of this thing tantalum Cl3, tantalum Cl3. So and this is like one hexane will be one hexane will be as a product. So here you can clearly see that tantalum Cl3 is the active catalyst, and 5 member and 7 member intermediate is formed during the catalytic reaction. Okay, so this is the option A, C, and B, D will be the right answer for that question. Okay. Next question is the substrate of the dimensional process is or are. So here you can see that we can have that component F's and is or are. So as I already told that is or are having does not guarantee that it will have more than one option correct. So it may be that MCQ type question also, just to confuse they provide S or to look like the question at the MSQ. Okay, so this question I have already discussed in starting that this thing is undergo the dimerization reaction, and then hydrogenation reaction is a reduction to give, and this overall process is called the dimerization process, and here the substrate is this. So this is the substrate that is called the propene. Propene. So not propine, not ethylene, not acetylene. So here the substrate will be propene. So option D will be the right answer for this question. So option D will be right answer for this question. Okay. And going back to the next, so the completed half of the question from today's discussion series. This the question number 5 is completed. We have another 5 questions for today's discussion. Okay, the metal catalyst used in the dimensional process is So we have already seen that this demonstration process is the propane that propane undergo the dimerization reaction. Undergo the dimerization reaction in presence of a catalyst. So here the catalyst used is the nickel. So in all this thing, nickel acts as a catalyst, except that thing which we discussed that. Mm, so here the option will be option number D, the correct answer. So here, so the dimerization process occurred. So this like this, like if you have okay, so nickel, if you have nickel and like the ligand L here and X is you can say that is an anion, and if your nickel is bound to such a fashion that it's an allyl group and nickel is in +2 oxygen state, then it can be transferred to another kind of structure which is maybe called the resonance structure, is have L nickel X, and this will be this. So this is that conversion of, so this is a sigma type of bonding interaction. Now this molecule can another molecule can connect by this con- pi pi bonding fashion should give the nickel like X. So these become sigma type of bonding, and these become pi type of, this is sigma and this is the pi. Now after this that this another molecule molecule may coordinate to this, and may insertion to this metal alkyl bond, and then the thing will undergo the dimerization reaction. So L Ni will be nickel and X. Now let's say this sigma bond, there will be the insertion towards here, insertion here, so then it will be like this, something like this, and then another portion remains same. Now this will eliminate eliminate from the reaction to give the corresponding active catalyst. So here the different phases of the reaction happen to give the corresponding product. So this is the one of the mechanism which is shown here, which gives the different kinds of product through this through this oligo dimerization reaction of propene to give the to propene, which is the one which give that dimer product, or alkene, which is subsequently hydrogenated to give the corresponding alkene, which is act as a, called the petrol. Okay, now uh, the active species is this, which is undergo the intermediate sigma pi arrangement to form this. So here one thing that to note that the coordination number is also changes in this step. This is also taken note from it. So this is only because the nickel, this second attack, that is the attack of the second ethylene molecule happened to this because nickel favored four coordination number square root or four coordination number which favored this attack for in subsequent steps. Okay. So propene will be the correct answer. The next is the nickel catalyst will be the correct answer. Next question is the catalytic nickel 2 intermediates in the following reaction is or are. So here one thing to note that we have to find where the intermediate is in nickel 2 oxidation state. Okay, so here the answer will be option A, which is nickel in the class 2 oxidation state. So other option is not correct. Also, if you don't know the mechanism for this reaction, it is very difficult to predict the answer for this question. So sometimes for the important reaction, the reaction steps or remember the intermediates is also become very important thing. Okay. So this will be the correct answer for this question. The next question is I will discuss this mechanism later on. This is the reaction is the important of cyclotrimerization of butadiene. So this reaction is example of CY cyclotrimerization cyclotrimerization of butadiene butadiene. So we will discuss this example. We have two questions from this topic, from this mechanism. So we'll discuss two questions together. So this is the option A will be the correct answer for this question. Next question is the catalytic nickel zero intermediate in the following reaction is or are. So the nickel zero intermediate for this reaction is will be, so here you can easily do this by the calculation of oxidation stage oxidation stage or state of nickel. You can easily calculate and say. So if you calculate that, so here nickel will be plus 2 oxidation state as we already mentioned in the previous question. So here also nickel 2 is in plus 2 oxidation state. You are the option C and option D, both you can see that cyclobutadiene and this one both are nickel in zero oxidation state. So this will be the right answer for this question. Okay, so now we can see that two different types of question can be from the same mechanism. So in this reaction, intermediate reaction undergo several intermediate. So some of the metal complexes or some of the nickel intermediate where the nickel is plus 2 oxidation state and whereas the nickel is 0 oxidation state. Okay, so let's discuss the mechanism for this reaction. So, so this is called the trimerization of butadiene. So we have first nickel 2 allyl complexes, nickel which is in plus 2 oxidation state. So we have nickel 2, let's say allyl complexes. Now in presence of this cyclobutadiene, butadiene butadiene along with the ligand, along with this it will undergo the reductive uh, elimination step, and these two will undergo to give that thing, this one. So now this will be converted to the nickel 0, intermediate. So that is the nickel in 0 intermediate, and this is the reductive elimination RE, reductive elimination step. And then you can have this double bond which is connected to this, and we have another double bond which is connected to like this way. So and here nickel in 0 oxidation state. Now if we have the oxidative addition of another butadiene molecule, so sorry, so this is called the oxidative addition OA. So now this will convert to like this, and these two will bound to nickel, and then nickel, and it will bound to this cyclobutane. Okay, now this can be converted to another intermediate species, that is nickel with this like this. So this is another intermediate thing for this. Okay, now this will undergo the another intermediate to give that following complexes. So that that we already said that this the oxidative addition, that is the oxidation of nickel 2 to nickel 2. So this will undergo this another in presence of another thing. So that will be, so this uh, so that will be another 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 system like nickel 2. Okay, now here is another intermediate, which is now this will undergo the another intermediate, which is the last question. There is a cyclo which is nickel act as again nickel 0. So this is also the RE step, that is the reductive elimination step, and nickel becomes again nickel 0. Nickel become again nickel 0. Now this will again undergo this thing to nickel 0 state, and which is again undergo to this. So again here it will be the product will be that cyclo octa tetraene, and that cyclo octa cyclo octa tetraene, and cyclooctatetraene, and that again that ethylene, two of that molecule will again uh, two of the cyclobutane molecule again will go to this oxidative addition step to give that nickel 0, then that will continue the cycle. So here one intermediate which is nickel 0, and here one intermediate which is nickel 0. So and here this is intermediate is nickel in +2 oxidation state. So here also oxidative addition, this one is also +2 oxidation state. So let me change the color. Okay, so the compound highlighted in these two blue color are in the nickel complexes, which is in the +2 oxidation state, and the which are the drawn in the red color are in the nickel in 0 oxidation state in this catalytic cycle. Okay, so with these two questions I think is very much clear. The next question is the product obtained is the cyclodimerization of 1,3-butadiene in presence of eta 3 C3 C2H5 Ni and PPH3 is or are. So as you have last reaction, we have seen that this product is from the cyclotrimerization cyclotrimerization reaction. So obviously this product of this C will not be the answer. So here you can easily eliminate the option C. So in between we have to check B and C. For that we have to know the knowledge of the presence of 1,3-butadiene in presence of this eta 3 C2 H5 eta 3 C2 H5 and PPH3 catalyst. Okay. So by the knowledge of other reaction or from the question of other reaction, we easily eliminated the option and got the answer. That eliminated the option, and that we got that the other two question, other three option, the options in between the other three can be the correct. So let's discuss. So the product will be, it can be option A and B and option C, D. So these three can be A, B and D, the right answer. Let's go to the mechanism discussion. So So this reaction is called the cyclodimerization. It's called the cyclodimerization reaction. So here we have the same compound or same catalyst, nickel. Okay, now this same catalyst will react with this, and in presence of PPH3 the reaction is happen little bit differently, like the previous one is also eliminate the dialkyl dialkyl product, that is the 1 2 3 4 5 diene product, and but the complex which is formed here is something different, like this. So here which is the similar types of complex which from there, but here in presence of ethylene molecule, here PPH3 is coordinated with this. Now this is formed after the from the same nickel 0 complex, nickel 0 complex. So one thing to note that here is in two state, and here is forming in presence of PPH3, same oxidative addition is happening, PPH3 or PR3. So depending upon the value of the PPH3 or PR3, several product is from. Now from this we can have that rearranged product with the nickel 5-member metallocycle, and then like this. Now this metallocycle undergo the reductive elimination step to form this and with the PR3. PR3. Now it gives the option A. Okay, so gives a cyclobutane ring, cyclobutane ring as a product by the reductive elimination. Now this compound also undergo the reductive elimination and give the same type which is formed previous, that is a COD, and that is the cyclooctadiene, and again each compound can be gives the another 7-member ring formation, that is nickel, that is 7-member ring formation like this, which will then undergo again the reductive elimination to give the corresponding 6-member six-member product like this. So these three products can be formed in presence of PPH3 ligands. Okay, so I think the question is clear. Now going back to the next question is, or as in the last question for today's discussion series, the material that exhibits. So in this to exhibit the shape stability on a short term is known as So this is a equal type question is called the option number B. So so you can see that so most of the questions related to this oligomerization, trimerization and cyclo oligomerization reaction we have completed in this week, and we have also discussed that nickel catalyzed on dimerization and trimerization reaction of cyclobutana, a normal N-butadiene substrate, and we have investigate the or seen the mechanism, and in the mechanism we have also seen the two important intermediate where the nickel resides in the nickel 0 oxidation state as well as the nickel in plus 2 oxidation state. This mechanistic part is very important during the answer of this kind of question, where how many reactant intermediate is there or which identify the correct reaction intermediate or catalytic intermediate, better to say the catalytic intermediate in this following reaction. So without remembering the proper reaction intermediate or reaction catalytic cycle, cannot possible to uh, do this. So and the last lecture of this week content is started with the another most important topic of this in the flow of application of organometallic compound in industry and chemical synthesis is the polymerization reaction, which is most important in industrial point of view or mm, industrial point of view. So but in this question series I have not include much of that. So in tomorrow in next day, that is the next problem solving session, we have tried to I have tried to maintain that this content overall only on the oligomerization and cyclooligomerization reaction from this nickel catalyzed and the utility of it. So next lecture or next session, next problem solving session, we'll try to, that is on 22nd March, we will discuss most of that we will discuss most of the most of the topics which is related to this polymerization reaction. To keep that topic entirely separated from this oligomerization reaction. I hope I have discussed most of that important topic and thing of the questions from this week content from the week content. Uh, uh, So with this 10 question discussion along with that mechanistic part of this most important questions, we have I have summarized that week content, most of the week content which is important in this week. So I kept that polymerization reaction totally apart for that next session. So when we will start discussing the polymerization reaction only, I did not combine this thing with the oligomerization reaction. So week 8 we have completed, and I believe that you got an overall idea how the organometallic compound are so much useful in different field of chemistry. So we have started the synthesis. We have started that alkyne synthesis, alkyne utilization of alkyne, that is mainly the acetylene, using the repe chemistry, and using that organometallic catalyst, and after that we move to that metastasis reaction, and we have several discussion with the metastasis reaction and different types of metastasis reaction. So after that we have discussed the oligomerization and cyclooligomerization reaction, followed by we will discuss in the next two sessions, that is the polymerization reaction. So that is so we have completed the 40 lectures on this, only the application of organometallic compound in this field of um, catalysis, which is industrially applicable, so which gives an overall idea how this compound is related or important in synthesis chemistry as well as in industrial process. So I will wait for another 5 minutes to see anybody joins, then I will try to do discuss some if anything remains from this weak content. Otherwise then I will leave for this session and see you in the next session. So whoever will watching this video, I encourage try to join in this live session, and if you have any doubt regarding this session, or if you have any doubt mm, regarding the assignments, or uh, exam pattern, or anything regarding this course content, or maybe the outside the course content related to chemistry, you can ask me to clear it, or you can get that doubt cleared. Or so I will wait for another 5 minutes to see anybody joins, because at the last moment sometime someone joins and start asking the doubts. So I will wait for a few minutes and see anything I left for discussing. I will try to discuss that at the end, and then I will close this session. just waiting for if anybody joins, or I'm just searching the thing if anything remains to discuss from this today's week topic. Most of the mechanisms of that dimerization, and all that thing, reaction with the PPH3 is also discussed, and the thing I did not find anything which is remained to discuss. Also the tantalum ClC, that is the ethylene dimerization reaction to produce the thing 1 hexine, is also I have discussed. Soap process is also discussed. Here you can see that nickel catalyzed. So just to take a summary, that's an alkene and alkyne oligomerization reaction. So ethylene oligomerization reaction, that is the soap process. The soap process is shell higher olefin process to generate the higher olefins, and where the nickel catalyst is used, and the nickel hydride is act as an active species, where the ethylene trimerization process to give that yeah, 1 hexene. We have already seen that mechanism of this process. Another thing is that here the tantalum is used an active catalyst, whereas the propane dimerization is also discussed, which is also nickel act as an active catalyst. Another is the cyclotrimerization of butadiene, which had also the nickel act as a catalyst for this reaction. So except the ethylene oligomerization, that is the Shope's process, propane dimerization, and the cyclotrimerization of butadiene, all are catalyzed by the nickel, and the nickel act as an key catalyst several, and the ethylene trimerization only the one process which is catalyzed by the tantalum, which is an early called to be the null. Okay. Something like so dimerization of the propane, we have seen that the actual catalyst is the nickel hydride species. We have also seen that nickel hydride is act as a active catalyst for this system. The high active catalyst for this system, the actual high turnover number for this nickel catalyst, the eta 3 C3Hp, that is the nickel to allyl complex with the bromine as a ligand, and PCY3 as a ligand, neutral ligand, along with the ethyl aluminum chloride, gives a high turnover number 6 into 10 to the power 4 per second. This also related with the enzyme activity, that is because of the high high catalytic turnover number, that is the 60,000 per second. So that then that we have also seen that cyclobutane, not cyclobutane, butane and big butane dimerization reaction, which is also catalyzed by the nickel, and that more important thing, that the cyclotrimerization of butane, that the intermediate which is formed that is the different reductive elimination. We have seen that the nickel 0 species, which is act as an active catalyst, and the nickel 2 species which form after the oxidative addition. So the different four species, that is the two nickel 0 species and the two nickel 2 species, which is act as an active catalyst, or in the, or you can say that the intermediate for this catalytic cycle. And the difference between the pre-catalyst and the active catalyst is the pre-catalyst, which is prepared in the branch, which is a stable molecule which is easily converted to the active catalyst. The catalyst is which take part in the catalytic cycle is called the active catalyst, but the pre-catalyst is just one step before the active catalyst, the one step before of this active catalyst, that nickel allyl complex, the removal of the allyl group and the reduction with the nickel 0 complex along with the along with the butadiene ligand is called the active catalyst. But nickel complex, but that is not highly stable, but that is take part in the catalytic cycle, so that is the active catalyst, but the pre-catalyst is the nickel allyl complexes, where the nickel in the +2 oxidation state. Also you have seen that uh, when I get that dimerization of dimerization of propene to give that different branched alkenes, which is hydrogenated, which is hydrogenated to give that petrol, which is an important compound. We have started the classification polymer classification. So we have seen different types of polymer, but in this series we have not discussed that polymer chemistry, because polymer in an application of this polymerization reaction is totally different. That is the and there are different types of molecular weights and such all. We have just started that reaction in this last lecture. So in the upcoming 2-3 session will be, or totally depends on this polymerization reaction, their reaction mechanism, the different types of polymer and their classification. So with that, I thanks everyone whoever is watching this session. So like if you are watching this videos in from the YouTube or recorded sheet, try to join in that online live session if you have any doubt, or you can also, if you have any doubt in from the my question which I am uploading in that drive, Google Drive, you can have you can send me the email if you which is written in the starting page of that. If you have any doubt regarding the portal assignment or the lecture which is uploaded in the portal, that you can post that in, also you can post that in the discussion forum. We'll try to answer, or that thing you can also ask me in this live session. So thank you for watching from the online mode. If you have anything, you can ask you to join live every Saturday 5 to 7 p.m. as no participants or very few participants join in the starting. So I close that session at least 15 minutes before, as when I finish the discussion. So if you want to discuss anything related to the course or related to the chemistry topic, please, I welcome you to join in the live session and get your doubt cleared. So again, I am introducing that I am an NPTEL PMRF TA for this course, to hosting this session, to completed my TA hours for this PMRF scheme, and also help the learners to understand that course content, week wise content, more in more detail, and remember that without solving that questions on every week or the topic which you are learning, without solving the question, it is not possible. or it is very difficult to learn that topic completely. So the problem solving is very important for every courses, every content. So that only that solving the problem will clear your doubt or clear your concept about this course, or about this content, so content which you are learning. So with that, I thanks everyone. I wish to see you in the next live session, that is on 22nd March, Saturday, from 5 p.m. to 7 p.m. Thank you for watching.